Hello. Today we are week 6 Tuesday, and we are thinking about different ways that we can express scales. That is our objective today, to explore some different ways to do that. So, since I'm trying some new technology for Mr. Peters, he helped me out with this a little bit, I figure we can look at some of the other work that we did today as well. So this was the practice check today. And I was interested in seeing how could you find the actual lengths and widths if you had a scale. And the scale here was a little bit interesting, a little bit trickier because we had centimeters to inches, both of which you might think would be a scale drawing. But we have information that centimeters in the drawing are going to become inches in the actual building. So looking at this, we have our scale drawing here. I'm just going to label that for myself. This is a scale drawing. Well, I want to turn things into inches, but first I need to have centimeters in the drawing, so I can do some centimeter measurements. I like my protractor because not only does it give me angles, it also gives me centimeter and inch information, so I'm going to start by seeing how many centimeters long is that pool. So we're going to be at about 5 centimeters long here, so I will label. My scale drawing is 5 centimeters, and along the height, we are at, let's say, about 3.8 centimeters. You might be a tenth of a centimeter off, but we're approximately at 3.8 centimeters. So if in my scale drawing I have 5 centimeters and 3.8 centimeters, let's think about how we could use a scale table to help us out here. This I know is the scale drawing, and I'm interested in finding what's going to happen actually. So I'm going to use my scale and put that in here. My scale is that 1 centimeter is going to give me 6 inches actually. How can I get from 1 to 6? I can multiply my number times 6 and then know that I'm going to convert to inches. So looking up here, well, if it's scaling, it's going to do the same thing. So I'm going to have 3.8 times 6, and I'm going to have 5 times 6. 5 times 6, whole numbers, gotta love that sometimes. We're going to have an actual window that is 30 inches on that dimension. And if I've got 3.8, well, let's see, we know that 3 times 6 is 18, and then 0.8 times 6 would be 4.8. So total, I would have 18 plus 4.8, or 22.8 inches. So that tells me that the actual width and the actual length are going to be 30 inches and 22.8 inches. And please do reach out if you're interested in seeing any of the homework from the previous day. I'm also happy to do that as well. Okay, so that was our practice check from today. Really thinking about how, if you have a scale table, how might you be able to use that to find actual distances? So then I showed this to students and asked them what they knew about it. We looked at a photo of it and people said, oh, it's something that goes in space. It is some kind of satellite or some kind of spaceship. In fact, this was the first lunar lander. So it was that first spaceship that got astronauts to the moon. And our challenge today was to figure out how big is this actually. People took some guesses, anything from about 60 feet to like 200 feet. And the push is how could we use scale and a scale of some kind to figure out how tall this is and how wide it is in real life. So we have these questions to guide us. And the really new and important thing to notice here is that this scale 1 to 50 does not include any units. So that just tells us that anything that we have, we're going to need to multiply by 50 to get our actual length. So I could make myself a scale table. So anything in the scale drawing is going to be 1, and that's going to correspond to 50 times that, anything in real life. So let's see. We want to find the length of the legs of the spacecraft. We know that its landing gear are its legs, and people looked at this in some different ways. Some people chose to look at just this length, some people chose to come all the way up. I'm, just for the sake of what we're doing right now, I'm just going to measure from here to here and say that's the legs, but the same idea applies if you go further. Looking at this, we want it to be in centimeters. We notice we're talking about centimeters, so I'm going to use the centimeter part of my ruler. And going from here up, from the down to there, that is 7.5 centimeters. So my leg here in the scale drawing is 7.5 centimeters. Well, 7.5, I'm going to need to apply my scale to it. I'm going from the scale drawing to the actual drawing, so I could do times 50. 7.5 times 50, well, 7 times 50 is going to be 350. Half of 50 is 25, so this is going to be 375 centimeters. And some students had 350, and some students had 400, depending on if they actually found 7 or 8 centimeters, kind of depending on how much of the leg they looked at. But just from there to there, it would be 7.5 centimeters. So then I asked students about the height. So let's see, we've got here 7.5 centimeters times 50 is going to equal 375 centimeters. So now we want to estimate the actual height. Once again, we need to find the actual value. So it would help us to measure the height. And I liked what some students did. They came and they said, well, this is how tall it is at the tallest point, and this is kind of where it is at the lowest point. So let's measure and see what that entire distance would be. And my protractor on its own isn't long enough, but I can make a marking at 10 and then keep going, and I end up with, oh, I'm seeing approximately 17 centimeters, approximately. Okay. So in here, we have 17 centimeters for the height in the scale drawing, and if we continue to go with our scale, we're going to need to multiply by 50. 17 times 50, well, 10 times 50 is 500, 7 times 50 is 350, so this would be 850 centimeters. And then I would say 17 centimeters times 50 equals 850 centimeters. That's the level of precision I need because we are going to the nearest 10 centimeters. But then I noticed 850 centimeters, that is a hard thing to conceive of because centimeters are small, so what is 850 of them? So let's think about what this would be in meters. Looking over here, 375 centimeters, there are 100 centimeters in each meter. So this is actually going to be 3.75 or 3 3/4 of a meter. 850 divided by those 100 centimeters in a meter, that's going to be 8.5 meters. Two different ways that we could describe this, thinking about that conversion to meters from centimeters. So now that we have Neil Armstrong was 71 inches tall when he went to the surface. This is in real life. He was 71 inches tall, not in my picture, in actuality. So now I'm over on the 71 inches on the actual side. I need to work my way back. Well, if I multiply times 50 this way, then to go back, I need to do the inverse, which would be dividing by 50. 71 divided by 50, that ends up being about, so that ends up being 1 2/5 approximately, or approximately 1.4 inches, because we have 70-ish over 50, which is like 7/5, which is 1 2/5, which would be about 1.4 inches. So if I wanted to draw him on here, I would go 1 and then just under 1.5, and that will be my Neil Armstrong right there. So a pretty big lunar lander, pretty big module to fit just 2 guys like that. They would fit kind of just in this part right here. Then if I wanted to sketch a stick figure of myself, I would go through the same process. So for me, I am 5'6". Oh, so let's say 71 inches divided by 50 is going to get me approximately 1.4 inches. Now here I'm about 5 feet 6 inches. But we want something that we can compare to in here. And I'm not going to talk about feet on this drawing. I want to talk about inches. So let's turn this into inches. I know that there are 12 inches in a foot. So 5 feet is going to be equal to 60 inches, because we can multiply that by 12. So I now have 60 inches plus 6 more is going to be 66 inches total. So I'm 66 inches tall. That's on this side. Once again, though, then I know I need to divide by 50 to get what my height would be. And in this case, I would be about 1 15/50 approximately, which would be approximately 1 3/10 or approximately 1.3 inches tall. So a little bit taller than, a little bit shorter than he would be here. If I drew myself in, I would now be like there instead of all the way at the top. So things to notice. Looking at this, first, when you know the drawing length, to find the actual length, we can take the scale drawing, multiply by the scale, and we will get the actual. Second, when we know the actual, we can divide by the scale to get the scale drawing length. So those are two important pieces of information. But we also notice something about scale here. That first off, this required no units. This was just 1 to 50. I was able to impose centimeters, I was able to impose inches on it as needed. So that means that when you take away the units, you open up flexibility for how you're going to view these types of problems. So let's apply that to this problem. We have a football field that's 360 feet long, and it's 160 feet wide. And we have two people who came up with two very different ways of describing this. Mr. Savage said that his unit is 1 inch to 40 feet, and he produced a drawing that was 9 inches by 4 inches. Mr. Pribick produced a drawing with a scale of just 1 to 480. He did not use any units, and he also produced a drawing that was 9 inches by 4 inches. So these two scales are in some way equivalent to each other. Looking at Mr. Savage's, we are saying 1 inch is going to give us 40 feet in actual. So then, how did he get 9 inches by 4 inches? Well, we know that in real life, it was 160 feet by 360 feet. We need to work this way then. So to get from 40 feet to 1 inch, we're dividing our numbers by 40. So 160 divided by 40 is 4. 360 divided by 40 is 9. And then we are going from feet to inches. So feet became inches. Feet, we now are talking about inches. Feet, we now are talking about inches. Mr. Savage imposed this inch to foot information in his scale. So you could just do your division of numbers and then say, there we go. Mr. Pribick did something different. He said everything is just 1 inch or 1 to 480. So in the scale drawing, anything that is 1 something long is now going to be 480 times longer, right? We would need to go times 480 to get to our actual length. So if we look at 360 feet times, that's actual. If we look at 9 inches times 480, so 480 times 9, we have 4,320 inches. But I need to get from inches to feet. So when we looked at what I did over here, we have 12 inches in a foot. So over here now, 4,320 inches divided by 12, because that's how many inches are in a foot, that's going to give me 360 feet. And that is how Mr. Pribick ended up with that 360 feet here. So we can say that for the 4 inches, when he puts 4 inches in, when he multiplies by 480, the 1,920 inches, when divided by 12, will get me to 160 feet. And so he circumvented having to use units because he just said, everything in the scale drawing, I need to multiply by 480. So I have to do something with inches, and then I have to get it to feet, since my original was in feet. So let's look at what that looks like just at the beginning of the homework. When I'm talking about, well, let's read. For each scale, convert units in order to make a scale that has no units. So my goal is to have something that is just a number to a number. So 1 inch to 1 foot, let me turn that into the same units. If it's 1 inch, 1 foot times 12, that would give me 12 inches. Now I can say that's 1 inch to 12 inches. Now I'm looking at the same thing. 1 inch to 12 inches. I could say that that's the same as 1 to 12. So for 1A, I would have 1 to 12. For 1 inch to 1 yard, let's take a look at this one as well. I want to get this to, again, numbers that are just on their own. So I need to get from inches to yard. Well, we know that 1 yard is the same as 3 feet. And we know that every foot has 12 inches. So that's going to be the same as 36 inches. So now I have inches to inches. I can say that's 1 inch to 36 inches. My numbers here would be 1 to 36. So you want to convert so that you have quantities that are going to have the same units, because then you can say, oh, well, I just take my inches and multiply them by 36, and I get the next number. My units at this point are not necessary because I'm just saying that whatever I have, I'm going to multiply by 36. So then down here, if we're going for an inch to a foot, well, we said an inch to a foot is the same as 1 inch to 12 inches, or 1 to 12. We've got 1 to 12. What else here is equivalent to 1 to 12? You could even think about that as fractions. What's going to be equivalent to 1 to 12? If you multiply by 2, for example, you would have 2 to 24. That's not on here. But do you see any other ways that you could scale it up so that you could get other ones? There are at least 2 more in here that are equivalent, maybe more. So that's what I've got for you tonight. Please reach out with questions. Now that I know how to use this nice deal, it might be even easier for me to show you some of my thinking. It was great to talk to many of the parents at Open House tonight, and I look forward to talking to you all more in the future.